Hey everyone, so today we're going to look at sample spaces and how they can be used to calculate probability. So if you think back to when we did sample spaces, there was three methods of listing the sample spaces. Remembering that the sample spaces are all the possible outcomes of a trial, or even two trials. So the first method that we used was the listing method, where we go through each of the outcomes one after the other without any necessary system. The second method was creating a two-way table. We're going to look at them today. And the third way was by creating a tree diagram, which we'll also look at today. So we're going to start off just by looking at the two-way tables. So here we have a question that wants us to calculate probability. And importantly here, if we read the question, there's two dice being rolled. And then their scores are added together. So if we want to know all the possible outcomes of something where two different experiments are happening, a two-way table is a really good way of doing that. Once the two dice have been rolled, they want us to find the probability that the total score is 7, then an even number, an odd number, a prime number, or a multiple of 3. So our first step, if we want to know the odds of getting any of these, is to figure out what all of the different outcomes are. So to do that, to list our sample space, in this case, we're going to use a two-way table. So we've gone through two-way tables before and how to do them, but we have the outcomes for the first dice, the outcomes for the second die, and then we fill out the two-way table, which shows if you roll a 1 and a 1, you get a 2. Because like they say in the question, the scores will be added together. You can just press pause and take a second to refamiliarize yourself with the two-way table. Make sure it makes sense that, say, for example, a 6 and a 6 will add together to give you a 12. But a 6 and a 5 will add together to give you 11. So the process we're going to use then is we're going to go through each of these parts of the question one by one. So we'll start off with part A. If we want to find the probability of anything happening, it's going to be the outcomes we're interested in divided by the total number of outcomes. So for part A, the outcomes we're interested in are the ones that have a 7 on them. So we can see 7 here, a little bit different color. If we count all of them up, there's 1, 2, 3, 4, 5, 6. There's 6 different places that we see 7 there. Out of a total of 36 outcomes. So we could count up each of the outcomes one by one, or we could just remember that a grid that is 6 long and 6 wide, we can multiply the two side lengths, so 6 times 6 will give us 36. This fraction can also simplify to 1 over 6. Or if you wanted to, you could give the answer as a decimal. For part B, it's going to be the same thing. We're going to look at the number of outcomes of interest divided by the total number of outcomes. So we already know there's 36 total outcomes here. So we're just going to see how many of them are even numbers. So we might guess that about half of these are even numbers, but we'll just have to go and look at them in detail to see. So we'll circle all of our even numbers here. And then we count them up. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we can go back to outcomes of interest and fill in 18 over 36. Of course, this then simplifies to being 1/2. For part C, the calculation will be exactly the same. If 18 of them are even, then the other 18 or the other half must be odd. So we can say there's 18 out of 36 there. And that's also going to be equal to 1/2. So we'll look at part C now. Part C, again, as before, it's going to be the outcomes of interest divided by the total outcomes. So they're looking for the probability that it's going to be a prime number. So again, we go back to our two-way table. We're just going to circle everything that is a prime number, or you can count them up separately if you want, but it might just be easier to circle them. So before we start circling, it might just be a good idea to refresh ourselves on what is a prime number. So prime number is anything that has only two factors, itself and 1. So for example, the number 3, its factors are 1 and 3. So it's a prime number. Whereas the number 4, well, the numbers that divide into that are 1, 2, and 4. So because it has more than two factors, that one is not a prime number. So if we start circling the prime numbers in the two-way table now, see that 2 is a prime number, 3 is, 4 isn't, like we said, because the number 2 divides into it. 5 is, 6 is not, because its factors are 1, 2, 3, and 6. 7 is, because it only has two factors. 8 is not, because the numbers 2 and 4 divide into it, as well as 1 and 8. 9 is not, because 1, 3, and 9 divide into it. 10 is not, because 1, 2, 5, and 10 divide into it. 11 is, and 12 is not, because it's got the factors 1, 2, 3, 4, 6, and 12. Now, as before, we're just going to count up the outcomes of interest. So we count how many factors or how many prime numbers we've circled here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that will be 15 out of 36. And because 3 divides into the top and bottom of this, we can simplify that fraction to 5 over 12. Or because they haven't asked for it in a particular form, we could also just give this in decimal form. And that's perfectly acceptable too. So that was actually part D there. And now for the final part, they're asking us for the multiples of 3. So we're going to repeat the same process again. A multiple is just something that's like in the timetable. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. That's the highest multiple of 3 we'll see on this table. So we can stop there. So we're going to circle all the multiples of 3. We're going to circle our 3s, our 6s, our 9s, and our 12. And now again, as before, we're going to get the number of outcomes of interest, so that's our multiples of 3, divided by the total number of outcomes. So our outcomes of interest here, we'll count them up. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 outcomes out of 36 possible outcomes. This simplifies to 1 out of 3 is our probability, or again, if you want to give it as a decimal, that's absolutely fine. The next question now, we're going to look at tree diagrams, one of our other methods of listing a sample space for two events. So, a fair coin, in this case, is flipped twice. They want us to use a tree diagram to determine the probability of getting two heads, a heads followed by a tail, then a tail and a head. So we could actually use the two-way table for this as well, but they've specifically asked for a tree diagram, so we're going to draw out a tree diagram. The tree diagram will look like this. When we flip the coin the first time, we can get a head or we can get a tail. If we get heads the first time, we get a head or a tail the second time. If we get tails the first time, we get a head or a tail the second time. You can see here it's divided up into the first flips outcome and then the second flips outcome. Down at the end, we actually list what the possible combinations were. So we call these our outcomes. So we could have got heads and heads, which is listed here as heads and heads. We could have got heads then tails, which is listed as heads then tails. We could have got tails then heads, which is listed here. We could have got tails and tails, which is also listed down here. So as before, what we're going to do to calculate the probability, so we're going to get the outcomes that we're interested in and divide it by the total number of outcomes. In this case, the total outcomes is 4 because we have 1, 2, 3, 4 outcomes. Be heads, 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 tails, tail, heads, or tail, tails. So for part A, they're asking us about the probability of getting 2 heads. So that's this outcome here. There's no other outcomes where we have 2 heads being got. So that's one outcome out of a possible 4 total outcomes. So our probability there is 1 over 4. For part B, we have a very similar setup. They ask us for the probability of getting a tail followed by a head. So we can look at our outcomes down below and see how many of those outcomes have a tail followed by a head. And that's just this one here. So that's one outcome that we're interested in out of 4 total outcomes. So our probability is 1 over 4. Again, you can give this as a decimal if you want. It should be 0.25. Then the final part of this question asks us about getting a tail and a head. And it doesn't specify which order like it did before. Before it said a head followed by a tail. Now it's just one head and one tail. Doesn't matter the order. So there's 2 outcomes where we get one head and one tail. It's the middle 2 here. So we've got head tail or tail head. So that is 2 outcomes out of 4 total outcomes. Simplify that fraction to a half, or we could write it as a decimal, which would be 0.5.